Hey everyone, welcome back to Web Dev Solutions. Today in this video, we'll see what is block finality. It's a point where transactions or block, once confirmed and added to the blockchain, becomes irreversible and cannot be modified. Now you might say that it's obvious that once a block is added to the blockchain, it cannot be modified. There is a situation when a block is even added to the blockchain, it can be completely replaced. This is where the block finality comes in and it's crucial. Now let us understand using visuals. Okay. So assume this is a Ethereum blockchain with over 3 blocks for now, okay? And what happens is two valid blocks are added with non-identical transactions at the same time, then there will be branch, okay? Now now assume this is block 4 which the miner 1 is submitting with a different set of transactions, and miner 2 will submit a block, the same block which is the block 4 with a different set of transactions. Now we might ask how do how both will choose the different transactions. Now it's up to the algorithm to pick the transaction from the mining pool where the transactions are stored by the users. Okay. Now miner 2 will pick a different set of transactions and miner 1 will pick a different set of transactions. Okay. So what happens is both will submit create Merkle proof and all. After that they will submit at the simultaneously. Okay. What happens is miner 1 will submit and miner 2 will submit, then there will be branch, because miner will say that here my block is valid because I have submitted it, and here miner 2 will also say that my block is valid because I have also submitted it, but both cannot be merged because they have a different set of transactions, so there will be a branch, okay, created by miner 1 and miner 2. Now what will happen is other nodes, some other nodes will start adding new blocks, creating new blocks in the miner 1's branch, and some other nodes will start creating blocks in a minus 2 branch. Okay, so what happens is here here the consensus used is like more longer the chain, the more valid it is. Okay, now here the finality comes in. Here the block 4 is added by miner 1, and block 4 is created like added by the miner 2 as well in the branch, in a different branch. Okay, so now other miners will add different blocks to it. Now there is a point where block 6 is added, block 5 is added simultaneously. You can think of it the same. Okay, now block 6 is added to the minus 2 branch first. Now the minor 1 block is not at up to the block 6, okay, but the minus 2 branch is up to the block 6, so this is considered valid, and this is considered to be invalid, in the sense this is the longest chain and this has the more number of blocks. This is considered to be valid, this is invalid, and those transactions which were considered to be valid before in the sense before in the block 4 are now invalid because this doesn't have that much amount of blocks which the minor 2 branch has. Okay, this is a simple situation where there is a collision between only two miners. There might be many miners which will be creating branch and all those things will happen. Okay, this is where the block finality comes in here, that like block finality in a sense here these blocks are considered to be final and these are discarded because these don't have enough number of blocks as the miner 2 has. Okay, so different blockchains use their own mechanisms to solve these issues. Like some use this kind of mechanisms where the longer chain is considered to be valid. Some might use voting mechanisms to vote which is valid and all, and different use different things. Okay, this is how the block finality works and how it's implemented. Okay, at present Ethereum is around block finality time of 15 minutes and it's obvious. Okay, you can read more about in their documentations as well. Okay, this is it, and if you have any questions let me know in the comments, and this is it. Thank you.